some laptop.
Hi, Hema. So it's Hema's Badri's birthday today. Hema's husband's happy birthday to Badri.
Yeah, thank you, Harun.
Happy birthday to Hema.
Thank you.
Hoping you will be busy today.
No, my laptop did not start actually, personal laptop. So I had to join from my work laptop and now it started. So
Okay. Switched back. Oh, no worries. Okay. All right. So let me get back here. Okay. So today I want to talk about the RAG, okay, Retrieval Augmented Generation. So we will go through a few concepts. I know in the last 3 classes we have been looking at the same architecture. By now everybody, I think, are very much familiar and recall all the components. So we will check. We'll go through quickly what RAG is. So we have already done the first part of it, like setting up the data, vector databases, generating embeddings, and retrieving the data. So the next step after this, the extension to this is whatever you have retrieved the data. So that data plus the question, the original question that the user has asked you. So you send both of these inputs to the LLM. So this is where we actually hit the LLM, like in the first session, like we did, right? ChatGPT, text based. So we take that LLM now and we pass that question to the LLM. Now, what is the difference? ChatGPT is also an LLM model, and you are asking the question, it is giving you the answer. So as we said, we LLMs have limitations, right? Like we talked about knowledge cutoff. So anybody want to refresh what is knowledge cutoff? It has a cutoff date.
yeah, recent queries, if you give after the data is trained, we cannot get it.
Yes. So every model comes with a cutoff date. Basically, till the point it is released, it has information. It has been trained on all the data, information to the point when it is released. Once it is released, then it has no knowledge of what is happening after that date. So that either it should get from external sources or you have to provide to it, right? So that's why we add, that's the first one. Second one is basically, again, we said, what is the second one? Private data. Okay. Nabi, do you want to talk about what private data is and why the LLM cannot help there or has limitation there?
No, I need to
Okay,
recall that.
anybody? That's fine. Murali, private data.
Like company financial data, company personal
Right.
data.
Yeah, exactly. Exactly. Thank you. So LLMs are trained only on the public data, publicly available data. Okay. Companies' private data is the LLM is not aware of it because we never published. It does not have knowledge. That's a private data. So if I want user to get information from my private data, then I have to I have to give it to the LLM to use it so that it can answer the questions. So basically, to overcome these two things, one is the cutoff limitation, knowledge cutoff limitation, and the second one is private data. So LLMs have limitations in knowledge cutoffs. RAG helps bridge this gap. So the recent events on the day one, we said on the chat GPT when we tried, we said what are the movies that are released in 2025 January. When it does not have, when we restricted not to use any external sources and asked it to give an answer from whatever knowledge it has on its own, then it failed. It said it does not have any knowledge of what's happening in 25. You can go to that resources on the internet or IMDb, whatever it said. So to overcome that, we can add a RAG. Okay, you can give what is the latest technologies, but that again is an when we go to agentic AI, we will see how we can give those tools for the latest thing. The second one is private data. So if I want to see my financial, answer questions of my financial data or events at my organization or at my company, which it's not public, private data, the say HR documentation or the customer service documentation, FAQs, so which I have not published, on the internet or wherever public knowledge. So those things it does not have knowledge. So when somebody asks about that, I have to provide that data to the LLM so that it can read, have the information of that, and then it is well prepared to answer the question in the context. So these two, to address these two limitations, the RAG is framework is used or implemented. Now, most of the commercial organizations, right, they have a need for RAG. Why would they just create a chatbot to answer general knowledge questions, right? They don't need. It is only for personal use. If I want to know about, I want to write some articles, I want to do some research, I want some information on that, I want to write some code, I want some help from there to generate that code, or I want to summarize some of my assignments or documents that I have written, I will use that. Okay. But as a commercial organization or a company, they have limited use for that, right? Some have some knowledge. For example, if a brokerage, right? So they will have use of all the knowledge that LLM already has on the financial data, which is public domain. Say most of the websites already publish the information about the stocks data and the financial health of the data. They are some public companies already published, right? So they have that data already available on the internet about the financial health, which the LLMs are trained on, and they have very good information of that. But apart from that, most of the organizations, they want LLMs to work on their data, use cases that are specific to their company. So that's where in the commercial organization, most of the use cases are the RAG based. RAG is just like ETL for organizations right now. Earlier, we had first ETL, then we had data pipelines, which is, I would say, advanced version of the ETL, where pipelines are, you have streaming data, or you have multiple ingestion layers, structured, unstructured, cloud databases, parallel processing, distributed processing. All of that came in, and they became the modern version of the ETLs. So when now AI is coming, the RAG will become the modern version of the pipelines, because whatever you have saved, we want that to be available for the users to interact with your data and get knowledge out of it. So for example, if you put all of the financial data and then connect it to a RAG with a retrieval augmentation, and then you give access, create an internal bot and give access to executives. So they can just type a question, show me the last 1 week's sales in this territory, right? So the agent or LLM will take that question, convert it, and see which data it has to pick from, run the SQLs. So that's again agents. So the tools, one of the tools can be your SQL function. So it knows which tables it has to go and check for, get the data, and prepare a report and give it to the user. So all of that is automated. Now the same thing, if you go one step backwards into the data pipelines world or data engineering world, it will still take some time, because the data is again available in the data engineering. You don't need to write a lengthy reports because you have all aggregated data. Then you have BI dashboards. So the BI dashboards, you can just click, and whatever available reports, it can quickly go and read from the aggregations and show you. So it's kind of one step previous. So one step below that. So the same reports will be available, but it will take some time, or prefixed date. So if your aggregations are at monthly, you can only check monthly report. If your aggregations are weekly, you can only go up to weekly. But if I want to do yesterday, that may not be available unless you have data aggregated on a daily, and then you can filter it. So those limitations will also be gone away once you give all of that data to the LLM and the tool to query those tables to get the information. And one step, if you go further, right, into the history, when there was only ETL, so all the reports has to be predefined. So probably, if you go 10 years ago, if you want something, a report, then it comes as a business requirement. Hey, this is the report that the executors want. You say, give me what, I can't do 80 reports. Give me top 5 reports, what you need. So you take that report, you analyze, you say, what are the parameters you need? What are the aggregations you need? Do you want a report by weekly? Do you want a report by quarterly? Then you put all the data into data warehouse. That reports, first you have to generate, first you have to build, you do the analysis requirements, then build the development of the report, then unit test, then send the reports for the what you call the business testing, UAT, user acceptance. Once that is done, that report is productionalized. Then you get at fixed time, you get that report gets generated, and then it is distributed. So that was the framework it was earlier. So from that situation, from that position, now we have come to the AI world where all of that is just a prompt away. So when you add all of these agents and tools, you give it, it just types in the question, it knows which tool to use in the agent, go and get the information, give it to LLM, it will generate the report and as per the prompt template and give it to you. So these are the advancements that are happening right from ETL to data engineering, data pipeline to RAG framework right now. Okay. So what are the use cases? We have seen here legal, health, sport, research. So all of that. So how does the RAG work? So basically all these slides that I'm showing you. So the way I take things is by the time I start reading the deck, you must have already been aware of all of this. It's not like, when I read, you should be immediately able to relate. So by this time, I assume that we have already covered all of these things. It's just reiterating, trying to connect what the document says back to what we have learned. Okay. So user query input, retrieve relevant documents from external knowledge base, pass the retrieved context. This is based on the embeddings and retrieval and all of that, along with the query to the LLM. Now generate a response using both the sources, the query, its internal knowledge, and the retrieved context that you are giving it to LLM based on the query. So you have a knowledge base, response accuracy, use cases, traditional LLM and RAG based. This is fixed, saying that it can only answer from the training data it has. So dynamic means that you can retrieve your own data and pass it to the LLM. So it is a dynamic. It may hallucinate when it does not know what you are talking about. It may hallucinate and try to give you some kind of made up answer. Here you can say contextually relevant, because whatever question you asked, you are providing that information. So it will be more relevant. Use cases, general chatbots. As I said, anybody who just want to have a general knowledge, document summarization, information about anything, research, articles, or whatever, all of that, code, all of that stuff. So this is domain specific and updated. So if you want to have your own organization, your own domain, that's where you use the RAG based model. From day one, we have been talking about the architecture of the RAG. So we did until the retrieval part, the first 4 things, where we said we take the documents or some text From here, read the documents, split the documents, put it in a vector store, which is your vector database. And when you get a query, so the embedding part is missing here. So embedding is also there between splits and vector database. You do the same embedding relevant splits. Once you get the relevant information from here, you send that in a prompt, both the query and the splits to the LLM to go through the relevant information and query and to get the answer. More detailed representation of the same thing we have been talking about. And we said we have already gone through A, B, C, D here on the left side. We have gone up to 1, 2, and 3. Okay. So the only part now is connecting the parts 4 and 5 to this. So once you get the relevant data, so we have embeddings, vector database, everything we have already done. The next part is once you get those results, what are we going to do with the results? Send those results along with the query to the LLM to go through and come up with a proper response, not just throwing that chunks. Throwing that chunks of data does not make sense, right? So that's where our LLM comes in place to go through that information and document a proper response. Okay. Now, what are the components of the RAG? I will ask you to start with. We have seen, right? So give me one component. Raju, one component starting of the RAG. You here, Raju? Are you mute? Okay, who wants to go? Anshu, you give me one component of the RAG. We just did shown you the pictures.
So I'll start with the last one, query.
Okay.
We have embeddings, and then we document embedding.
Okay, just
And,
give me one. I know I need
okay.
only one. Okay.
Okay.
So let's say you are saying. Okay, let's put one. So you said query.
Yeah,
Okay, user query. Okay, one component, user query. Okay, next, Hema. Any component of the RAG?
Okay, splitting or chunking and then embedding.
Only one. Okay,
Oh.
splitting, chunking. Okay. Anybody? Next, Nabi.
Retrieve.
Retrieving. Good. Retrieving or retrieval. We call. Okay, next. Who else? We have. We can try. Ramya, you want to try?
Vector database.
Thanks. Awesome. Vector database. Okay. Pawan.
Yeah, the data like which we feed into, which we split
Okay.
and
Okay. Data, documents, internal, whatever. Okay. Good. Murali,
Embedded model. I'm sorry.
who's this?
Raju, embedding.
Oh, awesome. Embedding Raj. Okay. Sorry. Embedding model. Okay. All right. Who else? Murali.
Yeah, and the LLMs. So depends
Okay.
on that.
Awesome. LLM. Okay. What else?
Output generation.
Okay. Output. Okay. Is that all? Anything else? Anything missing? Prompt. Right? Okay. Now put in the sequence.
prompt first.
Okay. Prompt.
Document first.
Okay. First document. Yes. So we will say, yeah, because we have two parts now coming in on merging, right? That's fine. So we'll say, yeah, documents 5 first. Okay. We have two, they go two parallel. Okay, that's fine. Yeah.
Splitting.
After 5, what comes?
Splitting.
Splitting. Okay. 2. Then
Embedding.
okay. Embedding.
Retrieval.
Vector database.
Vector
the
database.
Not
vector
embedding, right? What is embedding? Embedding is 6.
6. Yeah.
Okay.
Vector database.
Okay. After embedding, we go to vector database. Okay. Yes, vector database is 4. Okay. Okay. Then,
And then retrieval.
okay. Yeah. Retrieval. So retrieval is 3. Okay.
3. Yeah.
Now come back here. User query.
So query vector database. Embedding, right?
Embedding. Yes. So you take the query, then you
And
go okay, number 6.
uh,
Then
and then vector database.
yes, vector database.
And then model.
Retrieval.
Yeah, retrieval model.
So when it comes to 3, right?
Okay.
This is 3, this is 3. Now from both sources, number 3 should go to what?
LLM.
LLM. Yeah.
LLM will take a prompt,
Okay. Okay.
right? Now it goes to LLM.
Yeah.
Okay. 7. Now after LLM is
Output.
awesome. Okay. That's it. Now you have mastered the architecture of RAG. Done. So it's so simple. Okay. So all of that is what is here. That's it.
So before passing to LLM,
Mhm.
then is it searching relevant context, or before querying the vector DB, is it trying to get the context?
So the context is this, right?
Yeah.
Yeah.
So
So you take
if
the
it
query, generate the embedding.
to get the data, relevant data with context, right?
No, there is no context. Context means relevant data.
Okay.
Basically, these are both same terms. Somewhere they use context, somewhere they use relevant.
Okay. Out
Relevant.
of the DB query results, it will map the relevance, right?
Yeah. So when you are searching vector database, whatever relevant data you are getting is as per the context of the question, because the question also you are converting into the embedding using same model.
Okay.
So whatever retrieval that's happening, the data that is coming in out of vector database is your context related data, relevant data or context specific data. Okay. Right. So that's the exercise. Now the same thing we said, components of RAG: retrieval, vector database, search engines, generator, LLM to generate context aware responses. Context aware because we are giving it the context. That's what we are talking about, relevant data. That's the context. Embedding models to use, vector databases to use, all of this. And there are much more components that are not listed here that we have already seen. Chat and use cases, enterprise chatbots. We talked about AI retrieving internal company knowledge. That's the number one use case. And that's what the commercial organizations will look for to adopt. They don't have, there is no ROI in just giving a general chatbot. Healthcare AI, searching medical research for precise responses. So in the healthcare research, so they use domain specific LLMs. Like I said, there is a biomed LLM where all the medical related data the model is trained on the medical related literature, medical related data, all the research that has been happening. So only specific to the medical literature. So that makes the model less expensive because it's not trained on the all the data in the world, specific only on the domain specific data. One, two, the model is smaller again because it does not need extensive training or extensive resources. And then you get specific information so that it does not hallucinate, go here and there, because it does not know all of that information about movies, politics, governance, and all of that. So it only knows medical, and it has been trained on that, and you give a prompt only to give answers to the medical related information. So this is more useful, more specific for all healthcare companies, drugs manufacturing, like medicines manufacturing companies, the doctors, the hospitals, the surgeons. All of this is one of the hottest or most useful area along with fintech. So legal research is another thing which has been very hugely impacted, extracting laws and case studies where, in all the movies used to see the big books of all the court cases, judgments, arguments. We want to refer to the, previous cases. All of those things are now taken away because legal there will be domain specific legal models that are trained only on the legal literature of that particular country or the law. So you can easily document, and then you can easily come up with the or legal documents that you need, or the research that is needed for any of the legal cases that to be talked about. So this is another very important domain where the AI is going to help a lot. So e-commerce, recommending products. So this is actually been there for a long time. We already have seen Amazon, Netflix. These are already using the machine learning models for a long time now to give you, based on your search or based on your past history, based on the items that you have ordered earlier, based on movies you have watched earlier. So all of that already they have been using the machine learning models. So it's the same extension of that to use the AI to get onto these things, right? So these are some of the use cases. I see a very important or most useful in the healthcare and legal kind of things. What are the tools and frameworks? We will be seeing this today in the demo or into the next week, where we talk about the agentic AI. So LangChain, LangFlow, these are the frameworks. So LangChain is a framework, basically, which it's kind of an orchestration tool or a workflow tool kind of a thing for AI, where it will connect all of these components, right? So what we have seen here, so all of these components have to be connected. When you run, say, from user query all the way to the response, all of this has to be connected, right? Components. So that all of that is done by the LangChain. Okay. So LangChain is one of the frameworks, the earlier or the first frameworks. Now there are so many frameworks. We'll talk about that. But LangChain is one of the first, 22 when they released with the OpenAI. You have this LangChain to connect all of these components with LLM models, embedding models, retrieval and to prompt and to LLM output, all of that. LangFlow is again similar to the LangChain. The only difference is LangChain is code based, as you see the Python code. LangFlow is visual based. So it's kind of a drag and drop components that we will see when we do the agentic AI, where all the components, it's just like improving, right? So when you used ETL earlier, you used to write all the transformations by hand, or sorry, by code. Each function takes this and transform this, take this and transform this, and all of that. Later we got tools like Talend and Informatica, where you have all of that models built in. So you drag and drop, you give the input and then you give the output, and then you can just write the transformation. So it will take and do the transformation for all of that, right? Graph based or UI based or visual based, drag and drop kind of no code or low code things. So Langflow is the one of the same thing that you can use for building RAG or for building agents, agentic AI, for the same as LangChain. So for the framework. So we will explore LangChain and Langflow now things. So this we already know: Pinecone, ChromaDB, VV8, so many other vector databases that we have. OpenAI, LLM is again, it's not just OpenAI, just there. We have more than 200 plus models, or I think more than that, not just 200, what I'm saying. So many models available for the LLMs from different companies. Each company has, so many models. You have Meta models from Meta, OpenAI, Anthropic, and from the Grok. So many other things. NVIDIA, DeepSeek, so many models are there. And then there are models basically which are text based, audio based, video based. As I was saying, tools based on like Sora, Midjourney, all of these which are image based and video based kind of thing. So Llama Index is indexing and retrieval optimization. So we will also, not sure if time permits, if needed, we'll do this, but otherwise it's one of another models that will be explored in detail later. So that is the basics. We can get started into the demo. If you have any questions, we can talk about it now, whatever we have discussed. Any questions before we go into the demo? It will be a little, I would say a little more complex because we are advancing the first day, second day, third day. So we are advancing. So it will be a little bit intensive, but don't get overwhelmed. It's okay. You don't need to understand every line, every function, everything. You just need to go with the flow. What is happening? As I always say, code is the last thing you should worry about. Okay. So you should just know what to do. Okay. The how AI will give you how to do, and where all of that the AI will give you. You should know what to do. That's it. The design part, the use case part. Okay. So once you decide on, say, hey, this is my use case, these are the components I want to use, these are the models that I want to use, or this is the LLM I want to use, this is the embedding I want to use, this is vector database I want to use. Put all together, dump it, the AI will give you the code. Okay. And then maybe you have to change here and there, add few things, troubleshoot a few things with the help of AI, fix few things and all of that. So most of it is you need to have the business knowledge. Okay. Now let's go here. Before we go, we'll go to compute, start my compute. So today I will be using compute.
So Arun, you said that example as that one, right? The healthcare and e-commerce something, right?
Mm-hmm.
So for example, my industry is the retail industry. So can I get that one from import that one, the particular model which already developed, or the company has to develop that particular model?
Company will develop the model. See, basically, these are foundation models. Okay. There are two things. You can use the foundation model as is. Say, for example, OpenAI. So there is a OpenAI models that you can directly use. Then using that, you build a RAG system. So where you are adding your own information, retrieving based on the user query and giving it to that LLM as a context. That will suffice. Now you say, I don't want to keep ingesting all of that data into LLM. Second step is you can train the model on your own data further. So you take a base model and then you train the model on your data so that the model will remember or has all your data into it. So that is again a costly affair, training a model. So that will take some time and effort and money. So that's the second thing. Now, what I was talking about healthcare is there are some companies who have already developed that model or trained that model on the industry specific, domain specific data that you take, right? So you can use that will give you more specific answers. So more what you call, say for example, you are designing a RAG application or a chatbot for a healthcare company which specializes in the oncology, cancer related. Okay, some cancer hospital. So there are some patients they want to understand about oncology, about cancer, general questions, or based on their symptoms or based on their history, they want to check. Now they can go to ChatGPT also, right? And ChatGPT will give you the information. But again, ChatGPT will also have information about somebody who has written about the cancer patient, some stories or some emotional content or some pictures. So it has all of that information, and it will try to prepare an answer based on all of that. But you want only the medical related information, authentic information. So you should have some domain specific LLM. If somebody has already done, you can use that. So that's where you're saying. So it's the use case specific. But
So
otherwise,
these LLMs are the open source, sir, or we need to buy from the ChatGPT or some LLM companies there in the market?
yeah. So these are foundation models. There are some open, free, like ChatGPT. You are using it for free. You are not paying, right? But when you go for commercial, it has limitations. You cannot keep continuously using. It has some limitations. So commercial, you cannot use it. And personal also, after some time, it will say it has reached the rate limit if you use API. So it is paid. So either you can take subscription or you can take paper token model. Okay. So based on that, you will get those things. For example, if I say, let's say I'm going to Amazon. Okay. Amazon has a platform called Bedrock. So using Amazon Bedrock, you can build your RAG, you can build your agentic AI and all of that. So in this, you have agents, flows, knowledge bases that you can create. Okay. Use cases for the RAG. Now, when you go here, there is a model catalog. These are foundation models. So there is a model catalog, custom models, imported models, prompt routers, and all of that. So if you go to model catalog, it will tell you what are all the models it is hosting on the AWS. So somebody has AWS platform. So Bedrock, they can take subscription. Then all of these models are available for you to use. To use this means does not mean it's free. Okay. Now, marketplace. So these are all the providers. Which one you want? You want some model built by Amazon. So you can say what are the Amazon models. It's a Nova Canvas. And it's also saying what does its purpose is image to image. You give it an image, it will process that and then maybe find you similar images. Okay. It's kind of image search. That's what you are seeing in the apps and videos, right? If you take a picture and upload, it will tell you the scenario or the scene or based on similar things. And it is also used for shopping. So if you've seen something somewhere and you want to find, somebody is wearing a very nice shirt, you want to find similar shirts. So you have that picture and upload, and it will show you where it is available online to buy based on that picture, something like that. So there is Nova Light, text, image, and video to text. Give a video, it will generate the text based on video, what it is see. Okay. You have Nova Micro, it's all text based. And these are all serverless. So you don't need to worry about how many, what compute you have to use, what machines you have to use. It will automatically, based on your volumes, it will run serverless. It will use its own resources. Nova Pro, Titan. See here, text generation, code generation. So if you are a tech company you want to have a code generation help kind of a thing, then you can go for Titan text. Image generation, you want to generate images, background removal, image conditioning. So all of this. Embeddings. See here, if you want to use a Amazon model to generate your embeddings in the RAG, then you can go to use Titan text embeddings v2. It says vector size is 1024 default. Remember what is this 1024? 512 256.
Dimensions.
Yeah. So it's the dimensions, embeddings dimensions. It can be 1024 dimensions, it can be 512, it can be 256. But if you don't choose, it will give you default 1024. Text to image, image to image, right? So basically, this is all the available ones, right? Now, you can also choose, hey, I want to have something made by Anthropic, Cohere, DeepSeek. Okay, they have also have DeepSeek R1 already here. Right? So if you click this DeepSeek R1, I can use this model, text generation, Amazon Bedrock or Amazon SageMaker you can use to use this DeepSeek model usage. Okay. Now, so it will have like R1 models where you can, if you want to download, you can download from Hugging Face, blah, 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 blah. It's benchmarking against GPT-4, Claude 3.5 Sonnet, DeepSeek V3, OpenAI, DeepSeek R1. These are all these things. License citation. This. Now, so when you sign in, right? So it will tell you what are all the models you have access to. So you can sign up, add any of this if you don't have by default. So if you have access granted, you can use any of these. Now, each of these will also have a cost. That's what I'm trying to see. Where you can see cost associated with these models. License. The model catalog should get. Trading usage. You can open in Playground. If you want to test this model, chat model, you can go to Playground and then do, ask the question, whatever it is.
But if it is serverless, it's based on whatever we are provisioning, right? The memory and cores that we are using, right?
So the concept of serverless is that, see, you can have your own computing. Okay. You can say, I want to use these machines, this watch.
Yeah, by default, will they charge anything if it is serverless? That's the question.
No, only pay per use. Only whatever you are using, on that it will choose. See, it says to provide accurate, up-to-date weather report, I would typically check a reliable weather service. However, since I don't have real-time browsing capabilities, I can guide you on how to find this information. So we hit the first limitation. So it does not have current weather. So it's saying you go and check here. I can't help you. Now, when you go to agentic AI, what you will do is you will create a tool which can connect to get the weather information based on your question. So that tool you will provide to the agent. So it will use that tool. We give permission to use that tool. So it will connect to the internet using that tool, get the information and provide an answer. But basically that's not what we're trying to do here. I'm trying to see, okay, it'll be somewhere. Let's not waste the time. It'll be somewhere. When I find it, I will, cover it in the next class. It will, each model has a pricing. Okay. Overview. Chat texting, builder tools, foundation models. Let's see. Pricing for models. Okay. I don't know, somewhere it is buried. We will get it out. Okay, that's fine. But yeah, to answer your question, only they are not free. Some of them are open source. You can use for free on the Hugging Face, but some of them are like pay per view. So when you say OpenAI, it's a subscription model, $200 per month. Or you can use, there are some rate limitations again, or you can use pay per use based on your number of tokens you send it to the LLM via API and number of tokens it sends you back in the response. Okay. Okay. So yeah. So now what I have here is same this cluster I will use, and then I have this RAG chatbot, which is a RAG application. These are different notebooks. So all of this is Databricks. Now, this is a foundation, data engineering. Somebody is using a Databricks platform. It has everything just like Amazon Bedrock, what we have seen here. If you go to console home, you have this. If you go to Amazon Bedrock, you can you can choose the models. You can have the playground to check. You can build agents. You can build flows. Flows is basically your orchestration. Knowledge base is your document store. S3, Amazon S3, where your files are available. Guardrails you can put in the prompt, and then you can do evaluations, and then you can serve the model right here from here. So the same thing, same platform. If you are using Databricks, so Databricks has a platform where you can create workflows. You can create these notebooks like this RAG, and then using the models, right? So create a model here, and then you can do a serving of that model. So I will walk you through these notebooks, and then we will relate to what we are doing in the use case, creating the tables, uploading the data, building the chat, and then creating a model and serving. So that is the use case. Again, just concentrate, focus on the flow, how the data is flowing, how the RAG is working. Don't worry about how I will create model, what is the model, what is the serving. That is not the scope of this session. Okay, so you have to just understand after doing everything, you are packaging everything as a model, everything, and then you are registering it as a service where anybody can connect and send a question to that endpoint API, and it will run this RAG or this knowledge base, whatever query that thing on the right, and then give you the response. Okay, so first notebook here I have is creating the needed tables. So again, the same picture I have used here in this notebook. So we are familiar with this. Now I'm talking about the flow. This is again same kind of extension to this. It's in detail, much more detail. As you can see on the left, you have PDF files. What I am doing here in this, I am placing the PDF documents in a Unity catalog volume. So just think about UC volume as a storage folder for now. Just like here, if you go here, there is a folder here, right? Where you can add files. Now think of it, the same thing here as a UC volume. So how do I create UC volume? Is in the catalog. So I create a database called LLM, a schema called RAG. In that I will create a volume or a folder called PDF volume. So in this PDF volume, I have uploaded two PDF files. One is a gas range manual, one is a washer manual. Basically, it says the gas range. It's a company that sells the gas range cooks, stoves and the washers. Now they want to build a chatbot where customers can ask their questions if they have problems with their gas range or the washer. They can ask the questions in the chatbot. So that chatbot will get information from these two PDFs and then try to answer them. So that's the use case. Got it? Any questions before we proceed with the use case? I want you to focus on the use case, not on the code. So don't worry. I know how complex the code is. So many things I don't understand anything, Greek and Latin. That's fine. I want you to just understand this part. As long as that is done, code anytime you will be able to write. Okay. Are you with me?
Yes, sir.
Okay.
Yes.
Fine. Now, so this is the documents in the volume. Now extract, chunk, and load into a table. This is the next step. So same as what we are doing here, information extraction. So we are doing the PDF. Now, let's go here, try to connect the code with this flow. So first, I want to put the documents. Before that, I have to create some database and table, right? I created RAG database and then table rag schema dot docs underscore text. So this is my table where I am going to store the text information of the PDFs. Okay. So 1 second, let me see. Downloads. Do I have those PDFs here? Let me search quickly and show. We need to look at the documents right before we proceed into the use case, what we are trying to do. Okay, here was gas range. Okay, so these are the gas range manual PDF. So it has all the information, content, safety, some pictures, safety information. And then it has, if you go down, it has information of all the parts, oven, smart control, maintenance. So all of this information. Same thing, and you can also see troubleshooting. Okay, you smell gas. All burners, do not light. Surface burners do not light. Whatever this part. Same thing for the washer. You have this information of the washer. So these are the two documents that I'm using to build my FAQs or answer the questions from the user for this chatbot. Clear? Guys, come on. Unmute yourself. Talk to me.
Yes.
Okay. In one of the previous trainings, I was talking and then somehow I got disconnected. I didn't even know I was continuing the session for almost like 15-20 minutes. Then I realized that I have dropped off from the call. So please, time to time, say yes, no. Okay. So that I know you guys are still there. I'm still not talking to myself, still connected. Create table, docs track. So this is simple. This is just to see when you run this program again and again, just to see which files you have already processed, which are the new files that have come in. Okay, so there is a washer, there is a gas range. Suppose tomorrow the company is selling a new refrigerator. They started a refrigerator line. So they want to add that refrigeration document. So it will track, hey, I don't have the refrigeration document. So next time when you run, it will add that document here into the database. So just to track the documents. So that's all this is in the first notebook. We are trying to just create the tables. So all those tables you can see here. If you go rag, docs text and docs track. Documents text and documents track. Index will come later. I will show you what the index is. Now, we'll go here. Go back. Then, now I have to read those documents and then split it, right? Chunking, split it and write it to the database. I know we have to do the embedding thing. It's a little bit different in Databricks, how you create those embeddings. I will show you that. But for now, because we are not using any embedding model, we are just using the foundation model that is already there in the Databricks. So I will show you that. Now directory path, as we've seen, volume / LLM rag PDF volume, that is the, we have seen that, right? Volume where we have put the files. Now, as I said, don't worry about this code. All it is doing is list files in the directory. What are all the files available? Create data frame in Spark, file paths, index, blah, 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 whatever it is. All it is doing is listing the file names that are available. Okay. Now, same thing, volume here, processed files. We said already we are tracking what are the files that are already processed so that it does not do the, again, the same thing. Is it again? Gone to sleep. Okay. So we are tracking that. And then what are we doing here? With PDF Plumber is just a library again. Import PDF Plumber. It's a library to read the PDF files. So for PDF page in PDF.pages, extract text from each page, and then you have all text. It's just a processing. Okay, you are processing your each PDF file, and then you are using text splitter. From text splitter, you are using recursive character text splitter. You have to chunk, right? You have to split, cut down those text into the chunks. So you are using that. You are creating a splitter object, which is based on this recursive splitter. And what are the parameters you have to give? What are my separators? New line character. It can be empty space, it can be null space, or one new line or two new lines. You consider those as separators. Chunking size is 1000. Overlap is 200. So we talked about chunking strategy, chunk size, chunk overlap, length function. I'm not exactly sure what that means, but yeah, you just leave it. You don't. So it's just a len function is a length. If you want to, I think it is providing a function to use to get this size. So how do you get 1000 character size? It should know, right? So what is the function to use to get the length of the string? It is saying use len function. That is the function to use, Python function. Now chunks equal to splitter dot split text. So using this splitter, it is splitting the text. So basically all of this is done to split the text into 1000 characters chunks each. Are we clear till this part? We are reading the file and then we are using the text splitter to split it based on the chunk size 1000 and overlap 200. Okay?
Yeah.
Yeah.
Yes, sir.
Okay, nice. Thank you. Now, this is again all PySpark functions, pandas, array type, string type. This is all pre-processing to get the data. Get chunks, dummy, return, register, get chunks, all of this. Insert into docs text, whatever this is the text. Select, explode, get chunks UDF as text. So then what you are doing, you are adding all of that text that is processed into the docs underscore text table. So remember, there's until now, we are only doing the text part. We have still not come to the embeddings. So this is the docs text. How many chunks it has created from those two documents? 424 chunks. Let's say into 800. So those many characters it found in both the documents. So 424 chunks, and each chunk is 1000 characters. Since we are doing an overlap of 200, so distinct characters will be 800 in each chunk. Right? Now, docs track, we are just writing, okay, these files we have already processed. Now, once you write to the docs text, you go to catalog, LLM, RAG, tables, docs text. You can do the sample data, or you can also go to SQL editor here and then query the table, or you can do the sample data here. Okay, so these are the chunks that we have. So it will sample, it will show 100, but total there are 424, whatever it has shown. Now it's only text, right? Now once you created this, you go back here, the next step. So what happens after we chunk? What is the next step with the chunks? Anyone?
Create embeddings and insert into vector database.
Yeah.
So we have to create an embeddings using embedding model and then store it into the
Vector
vector database. Okay. So in Databricks, we already have something called Databricks Vector Search, Databricks Vector Store. It's already there in the platform. So how do we use that is you go here, go to docs.txt, this table, right? Within this table, if you see here, it gives you an option directly to do a vector search index. Okay. This is where it will automatically read this table generate the embeddings, and then store it in the index. So if I do this here, now it will ask what is the index name you want. Okay, I will say test index. What is the primary key? So you are building the index on this table, so it will give you the columns of that table. So I will say ID is my primary key. Endpoint. So I have to create a endpoint here. Okay, some endpoint so that it can come and search the vector database. So I'll say just no endpoints found. Okay. First create the endpoint. So let's say, so we'll see how to create the doc endpoint, the endpoint for the vectors. Columns to sync, all of this. Embedding source, you want to see here. You want to compute embeddings or use existing embedding column, which means that, let's say, if I already have embeddings generated using my own model somewhere, I can still go and use a NVIDIA embedding model and embed all of these data and create a column and then use that embedding column as the index. In that case, you have to give the embedding columns. So if you want to say, ask Databricks to generate the embeddings, you just have to give what is the column that you want to do the embeddings on, the text that you want to generate embeddings, and what is the embedding model. See here, it will automatically give you what are the models available to do the embeddings. BG large, Mixtral, DBRX Instruct, GTE large, MetaLlama. So any of these models that is available, you can use for embeddings. So, okay, so you can just use any of this as an embeddings. You want to sync computed embeddings continuously based on that. Sync mode is triggered or continuous. So if you are doing sync, if you put continuous, it will be continuously looping and looking for new data that is coming in. It will immediately sync it to the index, create the embeddings and add it to the index. And then you do create. So once you create, what will happen? It will create that index here. So if you go here index, it says, if you can see the sample data. So this is the sample data. And this is the vector. We have seen this yesterday also. So this covers your embeddings and vector database, right? Are we all on the same page?
Yeah.
Any confusion?
Yeah.
No? Okay.
Yeah.
Specific to Databricks, this is how you can create an index. And then it can automatically keep updating the, if you put it sync, it will automatically keep updating the index. Now, playground. So remember when we did these yesterday, when we built the embeddings, we were asking some questions here, right, to answer. So that you can directly query this endpoint. Okay. So query text, columns is text. You can do example. Such message, send request. See the response it gives you. Row count 3. This is the first one. Has orders, dry the washer, interior, blah, blah, blah. This is the distance. This is the second one. This is the distance. And this is the third one, chunk. And this is the distance. Okay, this is how you can test your embeddings. Retrieval is working fine or not at the high level. If you see here, the same thing, it also gives you a Python client. You can take this and then put it in your what you call Google Colab and run this. It should run from there as long as you give these workspace, client C, client ID, client secret, all of this, and then endpoint. It is already given. So if you provide these keys for your Databricks environment, it should run. Okay. But here we have tested this. So the first part is done, basically, right?
Yeah. Yeah.
We go here. So we have done PDF, extract chunk, vector index, BGE large and embedding send point. We're creating vector index, vector search point. So all of this part is done. So we have to do the RAG retriever and LangChain now. So for that, we go here, we go to the next notebook. So here I'm giving host. This is my Databricks workspace URL. It will get automatically here. This is my token. Okay. Index name is the table that I've created here, right? LLM RAG docs index. That is my index name. Workspace URL. Vector search endpoint is doc vector endpoint. So that's what I have created. So if you see here, endpoint overview. If you go here, serving endpoint is doc vector endpoint. So using this endpoint URL, you can connect to this vector database and then get your retriever. Okay, clear?
Yes, sir.
Yes.
Okay. Awesome. Now you are building the retriever now using that. So what are the embeddings? I'm using Databricks BGE large EN because that is the model that I have used for embeddings. So get retriever, use the host, vector search client, where I'm giving the Databricks token, which I have given here, Databricks token, host, access token. So we'll say get index. This is the index with endpoint name and the index name. So this is our boilerplate code. Again, there is nothing. So it's the fixed thing. If you write 10 RAG applications, only these variables will change. The code will not change. Only the endpoint will change and the index name will change. Okay. Then you are using that index, text column, embedding model, and you're creating a retriever. Okay. So when you use this, you will get the retriever. Now, chat model. So I'm creating the chat model now on the right side, where it will have my LLM model, it will have my prompt, and then it will give my response. Those three parts. So if you go back again to the picture, now I'm going to build this part. Model, this chat endpoint, LangChain, okay, and prompt. So this is the part here. Then we'll create the model and register. Okay. Okay, so this is here. Chat model is the endpoint this is my LLM model. Databricks DBRX instruct is the LLM model. Just like ChatGPT, OpenAI, just like Anthropic Claude. This is the model from Databricks, DBRX instruct. Max tokens is 200. It can take template prompt. I'm giving the prompt. So this is the system message. Whatever user question will go here. Whatever retrieval we do using the vector search, vector database will go here. So the vector results will go here. The question will go here. And this will go as the standard system prompt. We also looked at during the prompt engineering. It is telling the LLM model that, hey, you are an assistant for home appliance. You are answering how to maintenance troubleshooting questions regarding the appliances, blah, blah, blah. If you don't know the answer, just say you don't know. Don't try to make up. Questions appear for appliance you don't have data on, say so. Keep the answer as concise as possible. Provide all in English. Okay. So this is the template that I'm building. A prompt template is the template. What are the input variables? Is the context, and the question. So context will come from my retriever and question from the user. Now lang chain is retrieval QA from chain type. This is LLM is my chat model. What is the chat model? What I have built using DBRX instruct. That is my LLM. Chain type is stuff. Retriever is get retriever. That we have built here, retriever. See? So this is the retriever that will go to the vector search endpoint with the index name and get the results. Chain type KW args is the prompt. Prompt is what I'm sending as a prompt here in this. Then I can ask the question, what does the search message mean? And then I will run the chain with question and then print the answer. So basically, again, it's like checking the retrieval. I don't want to run this because I have to run all of the deploy all of the models and everything. Now, after that, register our chain as a model to Unity catalog. So whatever we have built, now we are converting into a model so that we can deploy. Okay, so we can deploy on the API and then use it. So this is all boilerplate code again, how to, ML flow, lang chain, you log the model that you create, Databricks, vector search, lang chain, all of that. The only thing you have to remember is the model name, appliance chatbot model. So this is the model name that you have to remember. So all of this RAG that you have built, you are packaging it and creating a model out of it with this name, appliance chatbot model. So when you run this, if you go to again LLM RAG here, so in the RAG, you have tables, you have volumes, and then there is a model. So this is the appliance chatbot model. Version 1, this is the model. Here, appliance chatbot model. Serve this model. When you do serve this model, it can create a serving endpoint that we have already created. It's already there, everything. So this is the model that you have created and serving this model as a API. Okay. So that's the model that you have built in the RAG. Now let me run this model. We have this. Okay. Okay. And then say use. Okay, state it is ready. This model is ready now. Let me see. Chatbot invocations, these things. So I have a client here. Okay. So trying to run this endpoint appliance chatbot invocations. That's what it says here. This is the URL. You can see this entire model is now serving at this URL. So if you hit this URL, you can connect to this model, which is your appliance chatbot model. So I can go here using this. Now you need the bearer token for access, and all of this is boiler code. Where did you get this? Where did you get this? You can go here and say use. Go to Python. See, everything is given. Just copy this, paste it. What do you need to change here? The Databricks token to connect. All the URL, the code, everything is already there. Now you have to run this model with a data set. What is your data set? So that data set I have written using pandas. This is the data frame query, and then I can call this method score model with this data set data. Okay, let me run this. Okay. So I asked a question, is it raining today? Okay, and then it says, I am unable to provide real-time weather information as I don't have real-time data access. I can assist with home appliance related questions, how to use or maintain them, and troubleshooting issues. Right? Now, what I will do is, you guys open your Google Colab, and then I will share this with you. I will share this with you. Now you guys can run and change your query and share it, and then run the queries and see how it responds. Since the API is up, you can connect from anywhere. So from your laptop, you can use the same code, and then you can run. Who wants to run this? Give me your email IDs. I will share this with you. Okay.
Yeah, don't mind.
Who's that?
Nabi.
Huh?
Nabi Naganti.Nabi.
Okay, let me see. Is that it? Okay. Anybody else want to try?
Yes, sir. Pawan Kumar, okay.
This one?
Yeah.
Okay.
Arun, add me as well.
Yeah. Give me, I don't have your email ID actually.
I
I
shared in
pasted on
the
the chat.
Chat, okay.
So we just have to run that code, right? Whatever you're giving. We don't need to add anything else except the library.
Yeah, you don't need to add anything. Just run it.
I don't know, I pinged my email ID as well.
Okay. Wait. It's very bad at this thing. Raju. Okay. We have everybody, Hema, Nabi, Pavan, Anshu, Raju, Murali. Okay. All right. I've sent it to you. I have stopped sharing. Okay. Now you guys, anybody who wants to go first, share, run, change queries, run and see whatever you want to see. Basically, it's if you want to check any of the troubleshooting, you can check. So I can give you some questions that are here in the chat.
I can share my screen. Is anyone else want to share their screen? I shared it yesterday as well. If not, I can.
No problem.
Let me share my screen. Okay.
Okay.
So you can choose one of this message and then you can choose one of the irrelevant information that it does not have and see.
Yeah, this is what I copied from yours. So you want me to change the query, right?
Yeah, just the query, nothing else. Okay. I think it gave you the answer. If you want, you can change the query to something I have provided. Ask something and one of those two questions.
Two questions you already provided, you're saying? Or?
Yeah, in the chat.
Oh, in the chat. Okay. What's the next? Which one here? Sorry?
No, I can't see your text. There are two questions I pasted, right? You can one. then replace the query.
I can't see your
Okay.
chat.
Oh, you
Arun.
can't see my chat?
No, I can't see Harun's chat where you
Yeah,
have
yeah,
pasted the
Arun chat.
question.
Yeah. I
Not
see last
my chat.
Murali's email ID.
I think
Yeah.
it sent in a direct message in staff group. 1 second, I'll try to call.
It's there to Raju. Okay. Send
Yeah.
to- because he responded last. Okay.
I think, yeah.
Yeah, the first line or the second one. Those are two different ones. You can choose that the oven will not turn on, or you can choose the second one.
Yeah. Predictions.
Now it's giving you the response.
Yeah.
Check if the oven controls are set properly. You can refer to page 24 of the user manual. Okay. Now, what I will do, I will send you the files. I will attach the files here. Okay. So you can open that PDF and cross check, search for that same question and see what it says in that PDF.
This is a PDF, right?
Yeah, search for that same question.
Yeah.
So
So it is not completely, yeah, plugged into electrical outlet. Can you see?
Yeah.
Make sure the electrical plug is fully inserted into your wall, properly grounded outlet. That is the action, the cause and the action.
Okay.
And if fuse in your home is maybe blown out, the circuit breaker may have tripped.
But does it tell you the same thing in the response
or
something else?
Yeah, I think it says that check if the oven controls are properly set. You can refer to the page 24 of user manual for instructions on how to set the oven controls. Ensure that oven is not overheating. If the oven is overheating, the door will remain locked. Yeah, blah blah blah. It's saying that it's not exactly the same text. Whatever we see.
Yeah, it's everything that is about the oven not
Oven,
turning.
yeah,
It gives you
yeah.
all the information to look at.
Uh,
So different things that you can try out. It's all do that. Okay. Yeah. All right. Next, who wants to share? Any question? Emma, you want to share?
Yeah, sure. So I tried the second question.
Mhm.
All beeps and information. So I got the prediction.
Okay.
Information code due to various reasons such as program sensor malfunction, overshooting, other issues. If it is malfunctioning, press off or clear, then restart the oven. And
Okay. So ask something that is not there in this. Yeah. Yeah. So it's the relevant information. Okay.
screenshot. Yes.
The oven is overheated. The control part of hot. No, that code symbol, right? When it comes the code symbol, that is the meaning of that.
Okay.
Okay. All right. So anybody else, or you want to ask something else, some irrelevant question? Emma?
Oh, do you want me to ask some other question? Okay. Okay. What should I ask?
Ask about weather, politics, festivals, whatever.
Okay.
Yeah.
I don't have.
Can't provide the exact launch date. However, I can tell you. What does it tell you? Oh, it still says developed by Indians. So it's the intrinsic knowledge it still has. So it's not behaving as provided in the prompt. It says it does not have latest information, but it's not supposed to answer that either.
Yeah.
Right? Yeah. So that's what, right? So you don't know. It's called hallucination. So no matter how much you have to put more guardrails, more prompting, and all of that to make sure it does not give you all of that information. Yeah, Pawan.
Yeah, I just added no, and I think it has started hallucinating. It says, based on information provided, here are some following steps for a washing machine that is not draining or spinning.
You added some notes.
I just added no in the query.
Oh, okay.
So wherever it is finding no, it is just capturing that.
Yeah, so it's just a raw thing that we just said, right? Anything context, you get it and provide as an answer. Now, when you are actually productionalizing the use case, you have to build all of that. What, the evaluation of the model that happens. How is the model performing, right? Based on the questions, what are the hallucinations? What is it answering? All of that is part of your model evaluation, guardrails, and then the LLM as judge, fine tuning, and all of that would happen.
Kind of
Yeah.
testing, right? User testing.
Yes.
Like what?
Yes.
Okay.
So how to fix these things? I mean, if I want to remove those kind of that hallucination things or whatever, I want to get the accurate result means.
Yeah. So that's basically your tuning of the model. You have to put guardrails in the prompt, more guardrails. You have to test and say maybe use different model if this model is not working. It's not maybe not very effective for the text DBRX instruct. So maybe you have to choose some other model, foundation model, so something like that, which is very good with the text summarization and text, question answer kind of a thing. So specific to those models that you can use, and then add more context in the prompt. Okay. All right. So that's the end-to-end our RAG application. I know it's a bit overwhelming again, because I have like added let me share back my screen, the Databricks component into it today, like creating the model and creating model, and then all of these indexes and model serving and all of that, features and experiments and all of that. So this Databricks platform.
Do we
But
have this
other than
on
Yeah.
GitHub somewhere so that we can try it out?
Sorry, can you come again?
Do we have this code in some GitHub or somewhere?
Yeah, I can publish all of this. I think it should be there. I can give you the link. But I think I can publish this. But yeah, you need to have the Databricks, Azure Databricks account. If you can set up that, and then you have to change this, get this workspace URL, and then change this, generate this token.
Yeah, those things you can mask and publish.
Yeah. So if you go to here, settings, developer, the access tokens. So here you can create a new access token, new token that can be used here. So the Databricks token, this part. Okay, to test. Yeah. And this URL you will get when you create that model, right? If you see here, so this is the URL. If you go to serving endpoint, you get the URL here. So this URL. But anyways, I mean, if you just say it will give you all that Python code. This anyway you have. You just need to replace your Databricks token and the URL in this. These two, if you change based on your environment, I think it should work. So I will publish the notebooks also onto this. But yeah, so not all of you, right? So not everybody. Don't worry about all of this, because this is who have already the knowledge of data engineering, Databricks platform specifically. Otherwise, it looks very overwhelming. What is Azure, Databricks, and Workspace, all of these notebooks, and then catalog, where you create these notebooks and all of that. We would do a simple, end of the day, yes, you have to create RAG applications and models. We'll try to do simpler ones next week. We'll try to do Amazon Bedrock, or one of this Python based. So if you see here, so this is also a RAG, just a simple Python code where I'm using the Amazon Bedrock. Okay, but this works on the local, and then there's a lot of installation that you need to do with the AWS CLI that you have to create, and then Python environment you have to create, and then you can run this. Okay, it looks the total code, if you see, is like less than 30 lines of code for the entire LLM. Okay, you are already using the Bedrock runtime. You are creating, this is all again comments. So you're just creating a prompt. But yeah, it's just not a complete RAG. It's just the LLM chatbot. You're asking a question, and then it's getting you an answer from the Amazon Bedrock model. Okay, it's not the complete LLM part, anyways. So not a RAG part. So we can try to build RAG also in the Amazon Bedrock. That's another use case. So we will see how we want to do the RAG application on the Amazon Bedrock in the use case next. And then we'll move on to the Langflow, basically UI. There you could see things are much simpler. You can do a RAG, and you can also do a agentic AI. So I think we should be, it's better to move. I'll check if Amazon Bedrock becomes simpler use case, or we go to visual elements like Langflow, where you can go ahead and then do a drag and drop of the components and connect all of those things. Okay. All right. Any questions before we wrap up for today? So as I said, I will not be taking classes tomorrow or the weekend. We will meet again on Monday. So I will, as of now, I plan Monday, Tuesday. Maybe we'll also have another session on Wednesday. So based on how we progress. But I want to make sure that we are all have the good understanding and comfort. I don't want to leave you overwhelmed and say, like feel, hey, this is too much. Maybe I don't want to discourage, basically. I don't want you to feel discouraged. If this is not done, we'll do it again, but don't worry about it. Even if, you go to interviews, they don't ask you to go through all of this. But all you have to do is you should be able to talk about, say, a model and serving the model. You should be able to relate and talk about, hey, I can create a RAG within the Databricks where I can create an index. I am using the Databricks vector search. Can create the index for the embeddings. I can use a foundation model. And then I can create a RAG application with the notebooks, create a model out of it, and then I can serve that model using MLflow. That at least you should be able to talk. Now, is there a use case that you have built? That is the next step. Okay, so when you want to prepare for the interviews, prepare for the projects, then you can say, yes, I have done Databricks, and then I have used Databricks to create an LLM. Or you can say, no, we have just used Python, or we can just use Langflow or LangChain. Something like on the visual code we have created and deployed on the Bedrock or whatever. You can talk about that as well. Okay, but either ways, don't get discouraged. You are learning a lot. There are too many things you are learning in a short period of time. It is understood that you will have some kind of anxiety, and sometimes you get discouraged, demotivated, but don't worry about it. If you keep doing it, definitely. See, you are almost like 40% of the knowledge you already have. Theoretically, you already know what is vector databases, embeddings. You can very freely use those terms. You can very freely talk about what an LLM is, how an LLM works, what is a RAG application, what are the components involved, what is an embedding, how do you use a vector database, how do you retrieve data. So all of this now you are comfortable, which means that you are already know at least about 40% of the entire GenAI. These are the basic building blocks, right? Now the next thing is, what are the different platforms that you can use to build these. So Databricks is one platform. Amazon Bedrock is one platform. DataStax, Langflow is one platform. So these are different platforms. You can build these RAG applications or agentic AIs. So next week we will talk one more use case about this, and then we will move on to agentic AI. So that will give you an end-to-end scenario of all the GenAI landscape. Now, are we able to build it? Yes, we will do simple hands-on right now, but then you have to go back, explore, and build use cases. And maybe you can come back and give me a demo. Hey, I have built this use case. Maybe in the next batch or next boot camp, I would invite one of you guys, to show me build something and give a demo in the second batch. Using this knowledge that we have built this kind of agentic AI. This use case we have built on this platform, either on Amazon Bedrock or Langflow or Databricks. So choose one, try to get some use cases. There are a lot of resources available, videos available. As I'm saying, so all of this, I have also learned from the resources available on the internet, the YouTube videos, the GitHub repositories, the notebooks that are available, the use cases, nothing that I have actually created. Of course, some code I have written, some debugging I have done, but most of it I have learned from the online resources. So it is all there. The most important thing is, at least first you have to understand the landscape, understand the terminology, understand what we are trying to do. Once we understand what is happening, the code part, yes, that's where you can work on that, and eventually you will get there. Okay, if you keep working on it, I think in less than 2 to 3 months you should be ready for a GenAI engineer role. That's what my strong feeling is. All right, so that's it. I do very small motivation talk, not much. So you should get motivated based on that. Okay. All right. Any other questions before we wrap up?
Harun, we need this recording, yesterday's and today's as well.
Sure. Yeah, I will post that. I think there was some processing issue on the yesterday's recording. I will do that. And I will post all of that into a new channel, YouTube channel, and then give you all access to that channel. So you can go and all the videos will be available on that channel instead of me putting it in the WhatsApp group. So all these videos I will post onto that channel. You can go and look at that specifically only for these videos. Okay. And I will also try to put some of these, all of these decks and the notebooks. We have to again, consolidate, and then I'll get it to you. I will work with Pawan and Ishrat so that you will get all those resources. All right, folks. Anything else? We are 5 minutes over. Keep practicing. Hopefully by tomorrow morning, I will publish the videos. You have 3 days. Please spend at least an hour or two per day exploring things, creating new use cases. We have so many components, so many vector databases you can try to explore, and share in that group. If you have questions, chat. Sometime we'll find a working session, probably Monday, Tuesday, sometime next week. So entire next week also I'm available. We can just continue and close the workshop on a higher note where everybody is comfortable. With that note, have a good night, everybody. Have a good weekend. See you on Monday.
Thank you, Arun.
Thank you, Arun.
Bye.
Thank
See you
you.
on Monday.
Thank you.
Have a good night.
Thank you.
Thanks, Arun. Bye.
Bye.